Hey guys, today we're looking at 5.4, which is going to talk about the sum and difference identities for sine and tangent. Last time we talked about cosine and kind of reviewed our co-function identities, and now we're going to talk about sine and tangent. So if we're looking at the sum and difference identities for sine, that's our first box right here. Sine of A plus B is going to be sine A cosine B plus cosine A sine B. And then sine of A minus B is going to be sine A cosine B minus cosine A sine B. Then our tangent sum and difference brings in some fractions. So tangent of A plus B is tangent A tangent B adding on the top, and then 1 minus tangent A tangent B on the bottom. And then tangent of A minus B is tangent A tangent B on the top subtracting, so tangent A minus tangent B, and then 1 plus tangent A tangent B multiplying on the bottom. So let's get some practice with these. Example 1 right here says find the exact value of sine of 75 degrees. So I need to think of two angles on my unit circle that can add to give me 75. The first thing that comes to mind to me is 30 degrees plus 45 degrees. So I would say 30 degrees is going to be my A, 45 degrees is going to be my B, and I am adding, so that means sine of A plus B. So I would have sine of A cosine of B plus cosine of A sine of B. So sine of 30 degrees, cosine of 45 degrees. Let's write that a little nicer. Plus cosine of 30 degrees, sine of 45 degrees. Now on my unit circle, the sine of 30 degrees is 1/2. The cosine of 45 degrees is root 2 over 2. Plus the cosine of 30 degrees is root 3 over 2. And the sine of 45 degrees is root 2 over 2. I'm going to clean these up a little bit. So if I have 1/2 times root 2 over 2, that's going to be root 2 over 4. If I have root 3 over 2 times root 2 over 2, that's going to be root 6 over 4. And I can write it all together as one fraction like we did last time. Root 2 plus root 6 all over 4. And there we go. Now let's do a tangent one, and let's get some more practice with those radians instead of degrees. So right here I've got 7 pi over 12. So just like last time, I want to try and think of things that will add to 7, but that are also factors of 12 that will kind of help simplify my fractions to things that would be on my unit circle. So what comes to mind to me is 3 and 4. So 3 pi over 12 plus 4 pi over 12. 3 pi over 12 is going to simplify down to pi over 4. And 4 pi over 12 is going to simplify down to pi over 3. And both of those are on my unit circle. That can be my A and my B. And I'm looking at tangent of A plus B. So that means I'm going to do the sum identity up here. So that's going to be tangent of A plus tangent of B over 1 minus tangent A tangent B. Now, this is where it does get a little bit trickier because remember our tangent on our unit circle is our y over our x. So if I'm looking at tangent of pi over 4, I've got to figure out what that is by doing the y over the x, sine over cosine. So tangent of pi over 4, that's going to be root 2 over 2 over root 2 over 2. And if I'm looking at tangent of pi over 3, well, pi over 3, the sine over cosine, the y over the x, well, the y value is the root 3 over 2 over the 1/2, the x value. So when I simplify these, you'll notice that I can multiply top and bottom by 2 to cancel out those denominators. So I'm going to get root 2 over root 2, which is just 1. So the tangent of pi over 4 is just 1. Same thing over here. I can multiply top and bottom by 2 to cancel out those denominators. So when I simplify this, the top is root 3, the bottom is 1, which is just the square root of 3. So let's kind of plug that into my formula over here, my identity. So I'm going to have tangent of a, which remember we said our pi over 4 was our a, so that's going to be 1, plus tangent of b, so that square root of 3, over 1 minus, and then I'm going to multiply them together, 1 times the square root of 3. So I get 1 plus the square root of 3 over 1 minus the square root of 3. And this is where the tangent gets a little bit tricky because I can't have square roots in the denominator, so I have to rationalize my denominator. So I'm going to multiply top and bottom by the conjugate of the denominator, bringing back that conjugate that we talked about. So the conjugate of the denominator is 1 plus the square root of 3. That's what I have to multiply top and bottom by. So when I multiply it on the top, boiling it out, first times first is 1, outside times outside is plus the square root of 3, inside times inside is another plus the square root of 3, and last times last, the square root of 3 times the square root of 3 is just 3. On the bottom, when I multiply it out, first times first is 1, outside times outside is plus the square root of 3, inside times inside is minus the square root of 3, and last times last, a negative square root of 3 times a positive square root of 3 is going to be minus 3. So right here on the bottom, those cancel out. So on the top, 1 plus 3 is going to give me 4 plus 2 square roots of 3. On the bottom, 1 minus 3 is negative 2. And then I can still keep simplifying that because 4 divides by negative 2, and this 2 in front of the square root of 3 divides by negative 2. The 4 divided by negative 2 is going to give me negative 2, and that 2 root 3 divided by negative 2 is going to give me a negative root 3. And there's my answer. Negative 2 minus root 3. So the tangent ones have a little bit more simplifying that goes into them. And then, just like we talked about with the last set of notes, remember these go both ways. You can start with the one that you need to expand by adding or subtracting two things, or you could start with it already expanded and you need to work backwards to figure out if it's a sum or difference of a sine or a cosine or a tangent. So if I'm looking at this one right here, I have the sine of 40 degrees, cosine of 160 degrees, minus the cosine of 40 degrees, sine of 160 degrees. So this is where you're going to have to really pay attention to like sine times cosine, like all that kind of stuff to help you tell if it's going to be a sine sum or difference or a cosine sum or difference. And then if it's a sum or a difference. So it's kind of a dead giveaway for sine versus cosine. If you're looking at these identities up here, for sine, it's sine times cosine. Whereas last time when we were looking at the sum and difference identities for cosine, it was cosine cosine and sine sine. So if you're multiplying by a different trig function, then that's kind of a dead giveaway that's going to be a sum or difference for a sine. And then also the signs match here. So if I have a plus b, it's sine times cosine plus cosine times sine. Or if I have a minus b, it's sine times cosine minus cosine times sine. So the signs match. So right here, I do have a sine times a cosine, which tells me that this is going to be a sum or difference of a sine instead of a cosine. And I can tell right here that it's subtraction, which means it's going to be a difference. So it's the sine of a minus b. I've got my a value, and I've got my b value. So I'm just going to plug them in. Sine of 40 degrees minus 160 degrees. Now, when I actually subtract those, I get the sine of negative 120 degrees. And negative 120 degrees actually isn't on my unit circle. But we do have some other identities that are going to be helpful here. If you remember, we can use our even-odd identities. So if I remember my even-odd identity, if I have the sine of negative theta, that's equal to negative sine of theta. So I can come over here and I can say that this is going to be equal to the negative sine of 120 degrees using my even-odd identity. And now sine of 120 degrees is on my unit circle. I can look at my unit circle, look at 120 degrees, which is over in quadrant 2, and the sine would be square root of 3 over 2, but I do have that negative in front of it, so it's going to be negative square root of 3 over 2 for my final answer here. So don't forget about your other identities and how they can help you when you're solving some of these equations or expressions. Okay, we've got another one that's kind of similar to a problem that we did in our last set of notes. It says write the following function as an expression involving functions of theta. So we've got sine of 180 degrees plus theta, but we want to get it down to just theta, no more 180 degrees. So I'm going to use a sum or difference identity here. And this is where you've got to be careful. You can't use the co-function here because one, it's addition, but also it's 180 degrees, not 90 degrees. So be careful with that. Don't forget what we talked about in the 5.3 notes. Remember, you got to be careful. So this one is a sum. I've got my A being 180 degrees, my B being that theta. So if I'm looking at my sum, I would have sine of A cosine of B plus cosine of A sine of B. So I'm just going to plug those in. So I'm going to have sine of 180 degrees cosine of theta plus cosine of 180 degrees sine of theta. And then I can use my unit circle to help me find those values. So the sine of 180 degrees is 0 times the cosine of theta plus, well, the cosine of 180 degrees is negative 1 times the sine of theta. 0 times anything is just 0, so that first term is going to go away. And then negative 1 times sine of theta is just negative sine theta. So we've written it as just a trig function of theta. And we're done. Okay, keep going. We've got some more examples on the back. Example 5 says write the following function as an expression involving functions of theta. This time we've got cosine of 30 degrees plus theta. Make sure you're paying attention. We're looking at a cosine, which was our last set of notes. This was our 5.3 notes. So if I'm looking at cosines, that's a different identity, remember? So my formula for this is if I have the cosine of A plus B, that's going to equal the cosine of A, cosine of B, minus the sine of A, sine of B. So here I would say A is 30, B is theta, and I'm going to plug it into that identity. So make sure you're paying attention to sine versus cosine versus tangent and using your correct identities. I know I've said it multiple times, but it's really, really important that you memorize your identities. All right, let's plug it in. I'm going to have the cosine of 30 degrees times the cosine of theta minus the sine of 30 degrees times the sine of theta. Looking at my unit circle, the cosine of 30 degrees is the square root of 3 over 2 times the cosine of theta minus the sine of 30 degrees is the 1/2 times the sine of theta. So unfortunately, we don't have anything that's going to cancel out like example 4 did. However, both of these do have a denominator of 2. So I could clean this up a little bit and make it one big fraction all over 2. I could have the square root of 3 cosine theta minus 1 sine theta or just sine theta and make it one big fraction that looks kind of a little bit nicer, but nothing cancels out here. And that's it. And let's try one that's got a tangent in it. So we've got the tangent of 45 degrees minus theta. So if I'm looking at this one, I've got my A here, I've got my B here. It is a difference. So that's using this identity over here, tangent of A minus B over, or sorry, tangent of A minus tangent of B over 1 plus tangent A times tangent B. Tangent of A minus tangent of B over 1 plus multiplying them together. So let's plug it all in. Tangent of 45 degrees minus tangent of theta over 1 plus tangent of 45 degrees tangent of theta. And we got to figure out what that tangent of 45 degrees is. So remember, that's your y over your x if you're looking at the point on your unit circle. So if I'm looking at 45 degrees, my y value is the square root of 2 over 2, and my x value is also the square root of 2 over 2, which means it's going to simplify down to 1. So I'm going to have 1 minus tangent theta over 1 plus 1 times tangent theta, which is just 1 minus tangent theta over 1 plus tangent theta. Because 1 times tangent theta is just tangent theta. Okay, that is just functions of tangent theta. There's not anything else I can do to simplify that. So once again, it doesn't simplify as nicely as example 4 did. We've just got those fractions there. There's no more like tangent of 45 degrees. It's just the thetas. So that's all we can do. Now let's look at example 7. It says, suppose that A and B are angles in standard position with sine of A equaling 4/5, and pi over 2 is less than A, which is less than pi. And cosine of B is negative 5/13, where pi is less than B, less than 3 pi over 2. Find each of the following. All right, so we need to find, and I'm going to kind of section this off, sine of A plus B, tangent of A plus B, and then the quadrant that A plus B would be in. I did not section that off evenly. Scoot that one over. Right. So first thing, I'm going to start with my formulas. If I have sine of A plus B, that would be sine of A cosine of B plus cosine of A sine of B. If I have tangent of A plus B, that one's a fraction. I'm going to be adding on the top and 1 minus something on the bottom. On the top, I'm going to have the tangent of A, and I'm going to have the tangent of A there, and tangent of B there. So I know some things, but I don't really know enough. So like I know sine of A is 4/5. I know cosine of B is a negative 5/13. So I could plug that in over here in my first one, but that's not going to help me at all with my second one where it's all tangents. So this is where I'm going to have to use my SOHCAHTOA, make some triangles. That's going to have to help me out. And that's also where them telling me that A is in between two values and B is in between two values, that's going to tell me what quadrant I'm in. So real quick over here, because we're also going to have to figure out what quadrant A plus B is in, I'm going to go ahead and draw a coordinate grid. And remember, we've got 0 here, Pi over 2 is the top, pi, and 3 pi over 2 is down here. So if we have that a, we have pi over 2 is less than a less than pi, well, that's going to be over here in this quadrant. So I'm just going to put a little a because a is going to be in quadrant 2. It's in between that pi over 2 and that pi. And then it tells me pi is less than b, less than 3 pi over 2. So pi down to 3 pi over 2 means b is down here. So I can put a little b here. Now it's going to help me a little bit when I have to come and draw my triangles in a second. So I'm going to go ahead and fill in what I know in my first sine of a plus b formula, and then I'm going to draw my triangles to help me get what I don't know. So I know sine of a, so that one's going to go right here for this. And I know my cosine b, that one's also going to go in that first part, negative 5 over 13, but I don't know anything for that second part. So that's where my triangles are going to help me. So let's come over here. I know that A is up in quadrant 2. I'm going to kind of draw my coordinate grid a little lopsided to help me out over here. And I'm going to say that A is going up this way. There's A. And using my SOHCAHTOA, I know sine, so I know so. My opposite would be 4, and my hypotenuse would be 5. So I need to find that missing side. I can use my Pythagorean theorem to help me. A squared plus b squared equals c squared. 4 squared plus b squared equals 5 squared. So 16 plus b squared equals 25. Subtract 16. B squared equals, well, 25 minus 16 is 9. Take the square root. So b is equal to plus or minus 3. We're going in the negative x direction, so it's negative 3. I can then use that to help me find the cosine of A and the tangent of A for the rest of my problem. So I'm going to plug that in here. Cosine of A would be adjacent over hypotenuse, so negative 3 over 5. And then we'll get to the tangent stuff in a minute. We'll just stick with this one for right now. And then I also need to look at B. Now I know B is down in quadrant 3. So I'm going to, once again, kind of draw it a little lopsided. Give myself a little more space over here. But I know it's going down this way. Okay, and I know cosine, so that means I know so I know the adjacent and the hypotenuse. I'm going to do a negative 5 here and 13 here. And I'm going to use my Pythagorean theorem again to help me. So a squared plus b squared equals c squared. Negative 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. Subtract the 25. So b squared equals 144. Square root both sides. So b is equal to plus or minus 12. We are going down, so it's going to be negative 12. So I can come over here and fill in that sine of b using so. Opposite over hypotenuse would be negative 12 over 13. And knowing all of that, I can now figure out what my sine of a plus b is. So I'm going to multiply first 4/5 times negative 5 over 13. 4 times negative 5 is negative 20. 5 times 13 is 65. Plus, over here, negative 3 times negative 12 is 36. 5 times 13 is 65. So negative 20 plus 36 is going to give me 16 over 65, and that would be the sine of a plus b. Now I need to figure out my tangents and plug all of that into my tangent equation over here. So I'm going to go ahead and put in the basics of it. And tangent is going to use my TOA, so opposite over adjacent. So for A, tangent of A, opposite over adjacent, would be the 4 over the negative 3. For B, my TOA, opposite over adjacent, would be negative 12 over negative 5. The negatives are going to cancel though, so I'm just going to do 12/5. And this one's going to take a little bit more to simplify. So what I'm going to do is I'm going to notice on the top to get a common denominator, if I have 3 and 5, I need to multiply this one top and bottom by 5 and this one top and bottom by 3. So for the first one, that's going to give me 20 over, I'm going to put the negative in front, 15. And I have plus. Then over here, well, if I have 12 times 3, that's 36 over 15. And it's all over. I'm going to rewrite the 1 as 15 over 15. And then minus, well, 4 times 12 on the top is going to give me 48. And negative 3 times 5 is negative 15. So if you look here, they all have a denominator of 15. So the other thing I could do now is just multiply top and bottom by 15 to get rid of all of those little denominators. So now what I'm really looking at is a negative 20 plus 36 over a 15 minus a negative 48, or 15 plus 48. So I get negative 20 plus 36 is 16 over 15 plus 48 is going to be 63. Yeah, so there's my answer. And now, once again, you could simplify all that in your calculator, but remember you don't get a calculator for everything after this class, so it might be helpful to know how to do some things by hand. Now to find the quadrant of A plus B, I'm going to look at what's positive and what's negative and see if that can help me. So remember our acronym, all smarties take calculus. We figured out over here that sine is positive. So if sine is positive, that means that I have to be up here in quadrant 1 or quadrant 2. I can't be down here in quadrant 3 or 4 because my sine has to be positive. So sine of A plus B is equal to a positive value. Then also the second part, I figured out that my tangent was a positive value. So if I know that tangent of A plus B is also a positive value, well, I can't be over here because tangent's not positive there. So that pretty much limits me to quadrant 1. So that's where my angle would be. Whatever A plus B is, it's going to be in quadrant 1. And our last identity, we are going to verify the trig identity for example 8 using these identities for our last example. So remember, we can use all of the identities we've learned so far. So if I've got a sine of pi over 6 plus theta, I'm going to use an identity I learned today. And then that cosine of pi over 3 plus theta, that's an identity I learned in my last set of notes. So remember, when we're simplifying all of this, we're only going to work on that one side. We're not going to do anything on the other side. So let's start with that sine. This would be my A and this would be my B. So if I have sine of something plus something, that's sine times cosine plus cosine times sine. I'm going to do sine of pi over 6 cosine of theta plus cosine of pi over 6 sine of theta. Then plus, for my cosine, A and B, remember when I have a cosine of A plus B, that's cosine A cosine B minus sine A sine B. So I'm going to have cosine pi over 3 cosine theta minus sine of pi over 3 sine of theta. And then we need to go through and find what those values are on our unit circle. So sine of pi over 6 would be 1/2 cosine theta. Cosine of pi over 6 would be square root of 3 over 2 sine theta. Then plus the cosine of pi over 3 would be 1/2 cosine theta minus sine of pi over 3 is square root of 3 over 2 sine theta. And you'll notice something's going to happen here. If I have plus the square root of 3 over 2 sine theta and minus the square root of 3 over 2 sine theta, those are going to cancel. And then I also have half cosine theta plus a half cosine theta. 1/2 plus 1/2 gives me a whole cosine theta, which is what I'm trying to get to. So we've verified our identity. So I used a sum identity for sine, a sum identity for cosine, and then just did some algebra simplifying. That's it for this set of notes. Make sure you get started on your assignment that goes with this. Let me know if you have any questions, and y'all have a good day.